All right. Let me see if I'm actually connected here. Nope. Okay, here we go. All right, we are still dividing. And so yesterday we talked about the box method for division, and we talked about long division, and both are great methods for dividing polynomials. And again, our goal is to be able to factor polynomials, because when we can factor them, graphing is super easy. And so we have to come up, like we have certain methods that we can double bubble. Sometimes we can double bubble by hand, or we can do factor by grouping. But sometimes when we look at a polynomial, I'm like, I don't know if I can does it factor? And so we might want to use division. So, because that's what factoring it is. We're unmultiplying, which means we are dividing, okay? Now, we have one more method for division, and that is synthetic division. But synthetic division is super duper nice, super easy, except that it only works when dividing by a binomial with a coefficient of 1, meaning a 1x plus 4, a 1x minus 2. So on the problems that you guys were getting in Delta Math yesterday, we were a lot of like, hey, what if we divide by 3x minus 2? Or x squared, all right? Those only work with long division or the box method, okay? So synthetic division is very specific if we're dividing by a binomial, so it can only have 2 terms, and it has to be a 1x, okay? So the method for synthetic division, which I hope you all know, but maybe you don't, and that's okay. So for synthetic division, we always start with a box. And what we want to do here is, I like to call this thing, what we're dividing by is the divisor. This is the factor. It's in bubble form. It is the bubble x plus 4. What is the 0? Negative 4, okay? If you take that bubble and solve that, and I guess I shouldn't use the word 0, but x equals negative 4. So if we were to take that bubble and actually solve it, that value is what we place on the outside of our box here. And it is just like this. It's like it's just an L shape. Yeah.
Could it like dividing the x plus 4 to be under it, and then x would be able to equal negative 4 because that makes it equal to 0?
Well, hold on. Yeah, hold on that method. Okay, hold on that thought. All right. Then what we do is across the top of our little L shape here, we're gonna is our polynomial, but we make a shortcut method here. Hold on, don't really do what I'm doing right now. All we're doing is taking a coefficient. So synthetic division is synthetic. It is a process. It doesn't have a lot of meaning at this level, okay? But what we're going to do is we take just the coefficients. So the 1, we take the negative 1, we take the negative 27, and we take the negative 28. So all I'm taking from my polynomial are the coefficients. Now here's another thing. On the outside, we use the solution if you were to solve the bubble. Across the top, we just take the coefficients. But the other thing that you must have with synthetic division is making sure that we have every single term accounted for. Nothing is missing. There's no holes or anything, okay? So this is a crazy process, but this is how we set it up. This is how we start. And then the very first thing we do is we always just bring down the very first thing. So we bring down the 1. And then it's a multiply. So now I take 1 times negative 4. What's 1 times negative 4? And negative 4 goes in the next column. And now we combine. Negative 1 and negative 4 give me negative 5. And then we multiply -5 times -4.
Do you want to write this down now?
Now, oh yeah. Yes. Now you're writing it down for sure.
Because you were like, don't do what we're doing.
Yeah. So +20. And then we combine the column -7. Then we multiply +28, and we combine the column 0. Ladies and gentlemen, right here, the very last thing is your remainder. The remainder is 0. And what that tells us is we divided evenly. Okay? It divided evenly. There is no remainder. And what we've done is we've started with a polynomial and we divided out an x. So if we started with x cubed and we divided out one of the x's, what should we be ending with? X squared now. What we've got are the coefficients. This becomes a 1x squared, a 5x to the first, and a -7x to the 0. So this equals 1x squared minus 5x minus 7. So you have to put your x's back on when you're done. We took them off at the start. We got to put them back on at the end, but we divided away an x. So the power decreases by 1. All right, let's try another so you can see. Here I am in bubble form. X minus 2 is in bubble form. What we need to solve it. We get x equals 2, so that goes on the outside. And what goes across the top? 3, -22, 37, and -10. And we don't have anything missing. It's x cubed, x squared, x, and -10. All right, the process is bring down, multiply, combine. So bring down your 3. And then we multiply and combine. Multiply and combine. What do we get when we multiply? 6. Yeah? All right, combine. -16. Multiply. -32. Combine. -16 times 2? Yeah? Okay. +5. And then we multiply. 10. Combine. 0. What's the remainder? Remainder 0. And so when we divide by x minus 2, what is the leftover quotient? Squared. Good. 3x squared minus 16x plus 5. Okay. Let's try 14. So these had a remainder of 0. Here, we're going to get non-zero remainders. Same process though. We have a bubble form here, x plus 5, which means x equals -5. So -5 goes on the outside. What goes across the top? 1. Good. And there's no missing terms, x cubed, x squared, x to the first, and a constant. It's all accounted for. So bring down the first thing, then multiply and combine over and over and over. So multiply. Combine, we get -4, +20, -2, +10, +9. So we get a remainder of 9. And so our quotient becomes 1x squared.
Is it 9 over x?
9 over x plus 5. Yes, the thing that we're dividing by is still we're dividing by x plus 5. So it's remainder over divisor. Okay, good so far? You getting the pattern? Yeah? Okay, let's try another. Let's do 16 and 17 because these have missing powers. We're missing stuff. So you got to fill in with zeros. So this is really important. I'm going to go ahead and just rewrite this so we get x cubed. What's missing? Yeah, so 0x squared minus 49x plus 120, and we're going to divide by x plus 8. So that is the thing we have to look out for. All right, so we're going to use x equals -8 on the outside there. And what should I write across the top? Good. 1, 0, negative 49, 120. All right, bring down the first thing, and then multiply and add, multiply and combine, I guess I'm saying. All right, when we multiply, what do we get? Negative 8, combine. Negative 8. Multiply, positive 64. Combine. Positive 15. Multiply. Negative 120 is correct. Combine. 0. So we have a remainder of 0. So this one divides evenly. What's my quotient? Okay. Because we're dividing out an x. So if we started with x cubed and we divide away an x, we're down to x squared. Let's do number 17. Number 17, what am I going to use on the outside? Positive 9. And what goes across the top? Wow. Negative 9, you're right. 0x squared. 0x. And then the negative 1. You have to be very, very careful. You should have 2 zeros in there. And you always need a constant term. So if you're missing a constant at the end, you still need to have a 0 for the constant as well. All right, we bring down the 1, and then we multiply and add. So we get 1 times 9 is 9, and then we get 0, and then we get 0, and then we get 0, and then we get 0 and 0. Negative 1. Okay. X to the third power. Good. 1. X to the third power. Yeah, so we could do plus negative 1 over x minus 9. You could do it that way. You could do 1x cubed minus 1 over x minus 9 also. Okay, how are you feeling about that? We got one more thing. Okay. So now that you're very, very good at synthetic division, here's what we really want to be able to do. So the reason we like synthetic division is because it does make dividing quicker. And we don't have, sometimes when we look at something, and I look at this, I'm like, it has 4 terms, but I cannot do factor by grouping. So that's what I would try first, because if I can do it by hand, then that's so much faster every single time. But I don't have a GCF that will work on both of these. They would be different things, so I can't use factor by grouping. Brody, were you going to say something? Were you going to, did you have your hand up? No? Oh, okay, never mind. Okay, so here we are. We're going to suppose we are given a polynomial function and one of its linear factors. And if you're given one of your linear factors, then we probably can completely factor the polynomial by dividing. So use division to write this polynomial in factored form. Again, our entire goal is to be able to write things in doubles because doubles are super easy to graph, okay? And so if x minus 4 is a factor, then we can also determine the zeros of the function. So what we're going to do is we're taking our polynomial and we're going to use this information that if x minus 4 is a factor. So let me ask you, first of all, vocabulary. What are factors?
2 things that we multiply.
2 things you multiply. So for instance, 3 times 8 are factors of 24. Okay, so 3 and an 8 are factors of 24. And what's nice is if you know you have a factor, if we do division, we would get 8 remainder 0. So if you know you have a factor, then we also know that we're going to get a remainder of 0 if we divide it, because that's what factors are. All right, 24 divided by its factor of 3. goes in 8 times with no remainder. That makes sense, right? Okay. So if we are told we have a factor, then I know if I divide, I should get a remainder of 0. So that's what we're going to do. We're going to use this information to set up some synthetic division. Here I have x minus 4 is in bubble form. What should I put on the outside? 4. And what should I put across the top? 2 and 8. And we can do our division. So bring down the 1. Multiply. 4. Combine. Multiply. Combine. Multiply. Hey, remainder 0. Look at that. And so it turns out that if I want to rewrite this function, f of x equals x cubed minus 5x squared plus 2x plus 8. What we just did is we said, hey, when we divided by x minus 4, the leftover bit, the leftover quotient here is x squared minus x minus 2. So if I take my bubble times this quotient, you would multiply together and we'd get that. Yeah? Okay. But we want to keep going. We want to keep factoring because that's our goal. And here I see a trinomial. Can I double bubble this? Yeah. So that's our goal, is always to keep double bubbling if we can. So let's see. X times x is x squared. And what times what is negative 2? Negative 2 and positive 1. So this is completely factored. And I know it's completely factored because everything is x to the first power. So it can't go any further. And then, what are the zeros? 4. X equals 4, positive 2, and negative 1. So once we have it in bubble form, super easy to find the zeros. And super easy to graph. And this is like the ultimate goal. So let's try another. Let's try number 18. So it says, given the polynomial function and one of its factors. So here we have a factor, and a factor means that it's going to give us a remainder of 0. What's missing in my polynomial here? An x squared. Okay. What are we going to use on the outside? Positive 7. And so we have 1x cubed, 0x squared, negative 37, and negative 84. I'm going to go ahead and do my synthetic. 1 times 7 is 7. 0 and 7 is 7. 49. Oh, that's math. That's too hard. 12. 84. And we do get a remainder of 0. So now my polynomial is my bubble, my factor that they told me, x minus 7 times what? Good. X squared plus 7x plus 12. And then we can double bubble that a little bit more. All right, x times x is x squared. What times what is positive 12? 6 times 2. 4 times 3? Positive 4 and a positive 3. So there is our polynomial factored perfectly. It's beautiful. And ladies and gentlemen, here is your number 1 testing tip for the day. 90% of math is manipulation. We are teaching you how to be manipulative, okay? All we're doing is using algebra skills to manipulate the numbers, to manipulate what it starts looking, what it begins at, and what it looks like at the end. These two things are exactly the same. Meaning, if we were to graph them, x cubed minus 37x minus 84, and my bubbles here, x minus 7 times x plus 4 times x plus 3. All I did was manipulate these things into their factors. But they didn't change. They should be identical graphically. Oh, I just killed it. Sorry. There we go. I accidentally hit an extra button and it spins it into freak out mode. There we go.
If there's like two of the same, like x minus 7 and x minus 7 again, do they cancel out? I don't know.
Nope. Right. So all it's doing is there'd be multiplicity checking.
So that's okay.
Mhm.
Though.
Yep.
If there was, do you just write one remainder or do you write both of them?
No.
The zeros or whatever.
Yeah. So we only care about distinct zeros. So we wouldn't need 7 and 7.
Okay.
Yeah.
You just need one.
Yeah.
Okay.
So here we have, what are the zeros now? Yeah, 7, -4, and -3. And again, you watched this graph, hopefully, and you saw that they should graph right on top of each other. So that is a common SAT question. Say, hey, here's your polynomial. Which one of these is also the same thing? When that happened out. Okay. Interesting. Now, number 20, last one. Number 20. They're telling me my factor is 2x plus 5. Can I use synthetic division with this? No, I cannot. So we're going to go ahead and do long division. 2x plus 5. Non-division, you don't have to change anything. 6x cubed plus x squared minus 27x plus 20. All right. Multiply. What times 2x gives me 6x cubed? 3x squared. 3x squared times 2x is 6x cubed plus 15x squared. I'm going to subtract everything. So I have 1 minus 15. That's a negative 14x squared. All right, and then back to the top. What times 2x gives me negative 14? Negative 7x. Negative 7x times 2x is negative 14x squared. Negative 7x times 5 is negative 35x. And again, I need to subtract it all. Negative 27 plus 35 is 7? 8. Thank you. 8x, bring down the 20. And then back to the top, what times 2x? 4. Positive 4. 4 times 2x is 8x, and 4 times 5 is 20, and we get remainder 0. Excellent. We should get a remainder 0. Okay. So then it turns out, if I take, I'm just going to write it to the left here because I don't have a ton of space. My factor, 2x plus 5 times the quotient, 3x squared minus 7x plus 4. That is going to give me my polynomial, and I got to try and double bubble the leftover bits here. Ooh, 3 times 4 is going to get me the 7. So 3x times 1x gets me 3x squared. I want the 4. Oh, wait a minute.
Minus 4 minus 4. Minus 4 minus 3x.
Oh, yeah, they're both negative. Right. Thank you. Okay, perfect. How do you know if you've double bubbled that correctly? What should you check? The outside and inside, yeah. So just double checking because it's a hard one here. 3x times negative 1 is negative 3x, and negative 4 times x is negative 4x, and that's where that middle term comes from. So there we go. All right, there's my polynomial. What are the zeros? Good. And positive 1. Good. Yeah, adding the 4 divided by 3. There we go. All right, questions for me?
How did you get the 0?
Skipping the step there, it would be 2x plus 5 is equal to 0. And then to solve for x, add 5 divided by 2. It is a delta math.